here on this workshop, we are going to learn about indirect calorimetry. Okay. So, how many people know what is indirect calorimetry or calorimetry? Yes, follow me. You know it. Okay. Okay. So, has anybody worked with it? अभी तुम मत हाथ ऊपर करना. Has anybody worked with it or seen or heard about it? Okay. What is indirect calorimetry? What is indirect calorimetry? So something which will judge the calories, it doesn't judge, but it estimates and measures the calorie. That's the difference. Okay. What we usually do is we predict the calories. How many other dietitians, nutritionists over here? How many of y'all? All are nutritionists. So what do you all do for your patients? How do you all must be calculating the calorie requirements, right? You all are taking ICU rounds as well. So how do you calculate those requirements of your patients? How are you all doing? As per the recommendations of disease specific related, and what equations are you using? Weight based, 25 kilocalories, 25 to 30 kilocalories per kg, right? See, again, what she just mentioned is we do not know the exact weight of the patient who is lying down on a bed, isn't it? All the more difficult to understand how much is the calorie requirements, and then what you're doing? Just approximating previous weight of the patient. Okay. Okay. So, a patient in the ICU who has come in with just post surgery with a healthy individual who has undergone an abdominal surgery, okay, and a patient who is a very sick patient who has got ARDS, all right, and on inotropic supports. Are the treatment going to be same for both these patients in our ICU? No, right? Are your requirements of calories probably going to be the same as per the weights? Will be same as per the weight base, right? You all are not going to do anything, any change otherwise, correct? So, does it mean that this patient's requirements and this patient's requirements are just the same? No, because we all know that every single patient who is in the ICU, their requirements are going to change as per their metabolism, right? And we all know when a patient is in critical illness, the stress on the metabolism is extremely high. They are hypercatabolic, they are in hypercatabolic state, and probably their requirements is more than what we are actually thinking it is, right? And what we are really doing is we are just predicting, right? Most of the patients, more than 50%, okay, as per the studies, more than 50% of our patients are malnourished in the ICU to start with. Isn't that something which is extremely difficult to understand? Very difficult, because they are already coming in with malnourishment. And if we are going to underfeed our patients or overfeed our patients, what is going to happen to our patients? They are going to be on a prolonged ventilatory support. They are going to be on a long stay of the in the ICU. Their morbidity is going to increase, their mortality is going to increase, right? So as a clinician and as a nutritionist, dietitian, what is our responsibility? To not allow the patients to become more morbid. We want to cut their ICU stay. We don't want the cost of the stay being so high. We are Indians, we cannot afford, because we are spending from our pockets. So every single day is a burden for us, right? Exactly. So for that, we as a clinician or a nutrition has a responsibility to deliver the adequate nutrition so that the morbidity and the mortality reduces, right? Fortunately, we have these predictive equations, we have these weight based things, but what is the problem with these weight based and the predictive equations? That there are n number of equations, isn't it? which to follow, what to follow. This hospital must be following one predictive, the other hospital is following the other. And we do not have any specific guidelines stating that the morbidity and the mortality reduces when you are using a particular equation, right? And at the end, and the most important thing is, they are less than 40% accurate. The accuracy of these predictive equations are less than 40%. Isn't that just too much? And 40% means most of that means 60% of the times we are feeding our patients wrongly. That means we are probably not doing a great job by following these methods and feeding our patients. Okay. So I am not saying, it is the studies which has said that it has got 40% accuracy. Yes. That's why I'm coming to it. So ideally, as per the Society of Critical Care Medicine, as well as ASPEN, American Society of Enteral and Parenteral Nutrition, as per their guidelines, if we want to provision our patient with nutrition and assess the nutritional requirements, the gold standard method of using and understanding energy expenditure is indirect calorimetry. It's not me who's saying that, it is the ISPEN, ASPEN, and your SCCM also states that this is a gold standard to understand what is the caloric requirement of a patient. Okay. So what are these methods? So these methods are near accurate measurements because it measures the caloric requirement, does not predict. It actually estimates what my caloric requirement is going to be. Doesn't this sound attractive? It does sound, because we are going to give that patient what he requires at that particular time. So if the patient's metabolism is low, if a patient is severely in mixed edema coma, their metabolism is extremely low, and we're going to blast them with a 2500 calories, what is going to happen to our patient? They are going to probably worsen, and probably the next day they're going to go on a ventilator. If a patient whose requirements are very high and I'm underfeeding, what is going to happen? They are probably going to be prolonged ventilated, isn't it? So that this answers everything. Okay. So that is the reason why indirect calorimetry is widely used in many countries. Okay. We have just started using in India. Okay. Our institutes use the maximum in Mumbai, I would say in India also, in fact. Okay. So what this machine is, okay. So this is a ventilator. Okay. This is a GE ventilator. All right. So the ventilator does not give us anything. Okay. But there is a box which you can see around, besides it. Okay. This box is a module. This is called as an Escovix module. Okay. Can you all see from there? So this box is called as an Escovix module, which is going to tell us the energy expenditure. Okay. So what does indirect calorimetry actually does? It will measure the heat production of a particular cell. Okay. What does it do to measure that? It will measure inspired oxygen, it will measure expired carbon dioxide, and it will give us the resting energy expenditure. Clear everyone? Okay. So for that we need some gas sampling tubings. Okay. So this is a ventilator and this is a circuit which goes to our patient. All right. So this is a flow meter of this indirect calorimetry. Okay. So this is a flow meter which gets connected to my patient when the patient is on a ventilator. Okay. Ventilator अपना काम कर रहा है, ये यहाँ पे connect हो गया. Okay. What happens is it is going to expel gases inside the lungs. There's going to be dilution of oxygen, nitrogen washout, and lot of other things are happening. And this is breath to breath. Each breath it is going to measure the gases. Okay. This will measure the gas exchange. All right. And at the same time, this is going to ventilate our patients. All right. So once this is attached, we have to make sure that we do not disconnect this patient for a while. Okay. we have to make sure when this machine is started, it first has to calibrate itself. Okay, so we need to calibrate this machine. We need to calibrate it. Okay, so that will take around 10-15 minutes. All right, once it gets calibrated and we connect this, there is a warm up time for this machine. Okay, the warm up time is somewhere near 30 minutes. Only after 30 minutes it will start showing the results. All right, so once we हे लाओ जरा. Okay, so once we connect this, there is a window on this monitor. Okay, here there is a spoon and a fork. Okay, on this window we have to click. Once we click on this window, this is for our metabolic parameters. All right, so what is seen over here is your average volume of carbon dioxide. Okay, so it doesn't measure the pressure, but it measures the volume of oxygen. It measures the volume of carbon dioxide. It measures your average respiratory quotient. What is our normal respiratory quotient? It's 0.8, right? VCO2 by VO2, volume of CO2 by volume of O2 is somewhere about around 0.8. Okay, that it will show. Then it will show variation of CO2 and variation of O2. What is that for? So we need this patient in a steady state. So now there is a cell, and what machine is doing is to understand the energy expenditure is it is going to tell us how much the gas exchange has happened and how much production of heat is occurred, correct? So for that cell has to be completely steady, it has to be relaxed, it cannot keep working. Means what? Means if my patient is breathing very fast, if the patient has fever, patient is breathing very fast, patient is very tachypneic, that means the cell is actual, it's not the actual this thing of the cell, but the cell is I mean it's breathing fast, the exchanges are very fast, rapid, therefore it is not a steady state. So that is not the real requirement of oxygen, that's not a real burnout, that's not the real energy which is burning. So what is the real energy which is burning is probably when the cell is in a steady state, wherein there are no movements of any molecules inside the cell. That is a steady state, and we need to achieve that to understand actual expenditure. Clear everyone? How do we understand that? On a ventilator, on this machine, how do we validate that it is in a steady state? So there are two things which we have to see. One is the variation. Okay, so this is our patient in the ICU. Okay, I've just clicked on this because we can't shoot on this. So what it is showing on my patient is this is a time interval. My patient has been attached on this ventilator and this Escovix from the this is the 17th May, this is 18th May. Okay, it will show complete 24 hours window if my patient is connected for 24 hours. All right. So what I have to search is I have to search for a steady state. What is steady state? Means that my VCO2, VO2, the variation, coefficient of variation, the variation has to be less than 5%. The difference between the two has to be less than 5%. If it is less than 5% and if my RQ is 0.7 or 0.8, that means to say my energy expenditure is accurate. That means to say that my cell is in a steady state. Clear everyone? Okay. So we cannot take just any reading. We cannot just take any reading. If this is 16%, 12%, if this is 1.2 and my RE is 2000. No. That is not in a steady state. Therefore, therefore this window is kept. Why is this window of interval? Because I will keep searching for a steady state. Jahan pe mere ko ye values, these values will keep changing when I'm moving my cursor here. Okay, and at one point my values will come below 5%, VO2, VCO2 and RQ will be less than it has to be 0.8 or 0.7. Clear? Once I get this reading, I will get my energy expenditure. Clear everyone? Okay, so this is the energy requirement for my patient. So this is going to be almost we have to give our patients 90 to 100% of this energy expenditure. So my calorie requirements should be somewhere around 1400 to 1500. Clear everyone? How often do we do this? If a patient is very critical, we have to keep doing it within 72 hours. If they are stable and they just require ICU for supervision, usually may not require so much frequent readings. Okay? We don't keep doing it every 24 hours. पूरे 24 hours में बार बार नहीं करते रहना है. We have to do it every 72 hours, fix our nutritional calorie requirements and keep it at that for 72 hours and leave it. Clear everyone? For proteins, it's the same 1.5 to 2 grams or 2.5 as per the disease specific. Okay, this is just for calories. All right. So once we decide on that, so since this is requiring gases to go inside the lungs, it is extremely important to understand that leaks should not be occurring in this patient. The circuits should not have any leaks. Okay. Secondly, a patient acutely, patient को तुमने ventilator पे डाला है, we have sedated the patient, done a lot of things to a patient, immediately we do not get the readings because steady state नहीं आया है. Correct? When a patient has just received a dialysis of 3-4 hours, immediately we cannot put the patient on an IC data and cannot get an IC data because again steady state. Okay, if the requirements of the oxygens are very high, say 70-80%, and the PEEP requirements are extremely high, 15, more than 15, we will probably not get a accurate data. Okay, and we need this GE ventilator machine to, because this module only can be attached to this ventilator. All right, so this is about a indirect calorimetry which we measure via GE ventilator. This is a CareScape R860 model wherein only this model has got a Escovix module. Okay, now let's learn about something which is more easily available, more easily usable in our patients of ICU. Can somebody just come ahead and volunteer for getting the Radharana? Okay, so this is again an indirect calorimetry. This is called as a metabolic, it can be called as a metabolic cart because this can be moved very easily towards our patient as against this, because this is a ventilated machine, we need a patient on a ventilator to check it. But with this, we can actually measure a patient who is spontaneously breathing, who is on NIV support and who is on a ventilator also. Okay, for this machine I said it usually takes, we will have to calibrate that machine and it will take 30 minutes of warm up time to start giving the readings. But with this, the best thing is that it has no warm up time at all. Okay, the moment we are going to connect to the patient, brother come sit here, Amrit, connect. The moment we are Alia, be on the computer, no? So the moment we are going to connect this patient on a on this machine, it will start auto calibrating and it will start giving results in no time. Okay. Oh, I'm so sorry. Okay. So once we switch on this machine, so these are the three modes wherein we can use this machine. This is a mask mode. Okay. This is a canopy mode. Okay, this just goes over a patient who's sleeping and we can calculate the this thing expenditure, and we have a ventilator mode as well. Similar to this, okay, this has a flow meter wherein the measurements of VCO2 and VO2 can be done and get our results. Okay, so in this gentleman, we are going to use a mask mode. Okay, we are going to just attach it as, we can also use it when a patient is requiring around 2 to 4 liters of oxygen. Okay, we can use this as a mask on the ventilator. Okay, this is not going to create any kind of suffocation or that the patient is going to feel suffocated. No, not at all. There's a filter over here wherein he can breathe through that very easily. Okay, there's no claustrophobia, nothing of that sort. So we attach it like a NIV mask. Yeah. This one canopy. Canopy mode. This is called as a canopy. इसको canopy बोलते हैं. This is Cosmed QNRG plus. QNRG. Cosmed का. हाँ. Yes. Patient is on a ventilator. I take this machine. I connect to the ventilator. This I've connected to the ventilator over here, and I start getting my readings. So the best part is this machine, we will usually get the steady state very quickly, because what happens with this machine is dilution is occurring in the lungs, the gas exchange is occurring in the lungs, and it puts in the Haldane's transformation and it will give us the result. But as against to this, what it does is it directly calculates the volume of oxygen, carbon dioxide, puts it in the wires equation, and gets us this REE. Okay. Now he is attached over here. What we can see on the screen is the, tell me. This one, yes. For the desirable time till the steady state is achieved. Once the steady state is achieved by, as per I said, less than 5% and 0.8 RQ, we immediately remove it. If we have achieved the steady state in 2 minutes, we can stop this measurement, and we can get that reading and immediately do. For this, it will take you minimum 30 minutes for the steady state to occur, because it is the measurement of the gases, the gas exchange occurring in the lungs, not in the machine. But why, as against this, inside there is a Douglas bag. Okay, there is a turbinator inside which will measure everything and give us the measurement of the heat production. Right, that doesn't happen over here. Everything happens in the lungs, and that is breath to breath. This is not breath to breath. That's why it is done also in the spontaneous patients. Okay, so once we have got this, we ask for a new patient. It will ask for a new patient. Select new patient. It will ask for these parameters, like most importantly height, weight, and gender. Okay, so first name I will put, I'm just putting something X. Okay, height I have to put, I'll put 170. Weight kitna hai? 85. So I'm putting weight as 85. Okay, so once I'm done with this, it will ask me to say okay. Can you all see? It will ask me to say okay. Then it will ask me which mode I'm trying to do. Okay, so here I'll ask for mask mode. It's showing me canopy mode, it is showing me mask mode, and your ventilator mode. Okay, so I'll click on mask mode. All right, now what is happening? It is auto calibrating. Okay, once it is attached, it is telling me connect patient circuit while calibrating. We have already connected the patient. Okay, so once it gets calibrated, it will start, say start, then I will start. Okay, this will take some time. So since these measurements are done inside the machine, the leaks over the interface does not matter at all. Like as against this, because this is going to tell us the dilutions of the gas exchanges in the lungs. It will get affected if there are leaks. But in this case, it will not, because because the pressure monitor nahi ho raha hai, volume monitor ho raha hai. So every bead is going to give us the measure the volume. Okay. It will take 2-3 minutes for the calibration. and then it will just start off. So these wires are the gas sampling wires. Okay. So from these, the your gases are getting measured inside this. Okay. So it started now. It's calibrated already. Now it will say start. Okay. So I start, and it will start. What it's saying, it is collecting the data which we have inputted just now. And once it starts collecting the data, it will start putting in that software. It will start putting in that bias equation and give us the data. So on this screen, what we are seeing here is the same thing what we are seeing over here. Okay, what we are seeing here is REE, that is resting energy expenditure. What we are seeing here is, okay, here there is RQ again, all right. Then there is VO2, that is volume of oxygen, and volume of carbon dioxide. Okay, down here there are two semicircular things you can see. That is a variability, coefficient of variation, which I said has to be less than 5%. All right, and here the same thing, volumes. Then it will say start recording. Once it comes as a, see, now it has. Okay, so is telling me start recording. So now the measurements have started. Okay, the test has started. Now what we are seeing here is going to be what we are going to look here. So now it will start giving us a graph. All right. Now this man is just sitting over there in a steady state where he's breathing very easily. Okay. In his case, we are going to get resting energy expenditure very quickly. Steady state बहुत जल्दी मिलने वाला है, and just now see what you are seeing is the machine has started testing it. All right, and the variation is just zero. That's zero because there is no change at all because he's breathing very heavily. The moment he will start breathing faster, this will start changing, and you will get a variation. So that measurement we are not going to pick up. Okay, so what we are seeing over here is variation is 0, all right, and his RQ is just 0.7, which is good enough. Okay, so his requirements are somewhere around 2000, 2000, right? So his actual requirements are 2000. As per the weight based, if you are calculating how much is he going to require, is 85, 85, 90. So 90 into 25, 90 into 25 comes to how much? 2000, 2200. Okay, so his requirements are somewhere around 200, 2000 over here. Okay, that's exactly what we are looking out for. Okay, sometimes some patients requirements are very high, and we, as per the weight base, we are giving them very low. So underfeeding, overfeeding is something which we can avoid in these patients, right? So see now what is happening over here. So so see, his requirements are going up. So now this graph, because the steady state is moving. Okay. So now in a patient who is like breathing very fast, or a patient who's got fever, is tachypneic, hyperventilating, the steady state will not be achieved very quickly. Okay. So in those patients where we are wanting to understand the resting energy expenditures, no, it is not that the right time to see. Okay. So let the patient settle for some time. let them become in this machine we just connect this patient, the ventilator does its work on the side, and from the side principle it just keeps giving us the measurements. Okay, and in the whole 24 hours it will give us a, this is a window of 24 hours, and we have to just go behind, see the interval wherein we are achieving those required readings, and we will get the energy expenditure. As against this, इसका हमको एनर्जी एक्सपेंडिचर बहुत ही जल्दी मिल जाता है, पेशेंट को कनेक्ट करके रखने की जरूरत नहीं है. You just connected 5-10 minutes, we get the reading. In his case, we got the readings, and immediately see now this is, see there's a graph which is going up and down, and his requirements are changing. Okay, so that means it is not the accurate readings. All right, so once we get these readings, fine, we validate with the RQ of 0.8 and a variability coefficient of 5%. We know our requirements are what is this showing. Okay, all right, any questions? Any questions on this? Any, any questions? Actually, RE is a resting energy expenditure. Your energy expenditure means your calories requirements. Huh. How do you find out the resting energy expenditure? How? So you need VCO2. How do you get VCO2? So you don't get VCO2. There are few modules wherein it will just give you VCO2, volume of carbon dioxide, which we can put it in a equation like how you have mentioned, and you can understand the, yes. But that is again not as accurate as this, because in that volumes they are not done in this way. How it is done in that will just give you an estimate of volume.